So as we start, we're going to be talking about problem solving in math and beyond. So let's get going. First, I would like to know is your views on mathematics. People come with lots of different views in math, and so I would like to know what yours are. So if you could write in the chat box if you either love it, you're okay with it, it makes you nervous, or you hate it. Because people come to mathematics with lots of different opinions about math. And none of them are wrong. It's all based on how you experience math as oftentimes as a child. So if you could put that into the chat box, I would appreciate it. All right, so I'm hoping that by the end of this, I've at least given you some ideas on how to make math more enjoyable for your students, how to help them with problem solving, and how we can really help to champion math together. So going on, what does it mean to be fluent in math? What does that mean? Does it mean that students are fast and accurate, or does it mean that it's thinking and strategizing to be fluent in mathematics? Any ideas which one you think that would be? You can write in chat box, or you can even unmute yourself if you want, like. So it means that fluent in math is that you're thinking and strategizing about mathematics. So as kids get up higher mathematics, that the calculations in mathematics are done mostly on a computer or a calculator these days. So we really need to get kids to be thinking and strategizing about what numbers mean and how to solve problems. And that's really the main purpose of mathematics. And so we really got to put more emphasis on that with our students. Mathematics is primarily problem solving. Mathematics is primarily about reasoning and not memorization. Like I said, most calculations are done via computer use or calculator. So being, mastery of math facts is excellent because it does help kids understand numbers better. But if it's just pure memorization that they're getting their answers from, they really need to learn how to work with numbers and be able to calculate how to get an answer. But the memorization part isn't as important as the reasoning and the understanding of numbers. Allowing students to develop and this problem solving helps students develop an understanding of how numbers are used. And it also allows students to explain the process on what they're thinking, as well as it's transferable to other subject matters and life skills. So the better that they are in problem solving in mathematics makes them better at other subject matters. And I'm going to show you some studies on that. So there was one study out of UC Irvine in 2011, which they looked at 20,000 kindergartners. And they found that students who had more time in math had higher math scores, but it also increased their reading scores, as well as they had developed better social skills throughout their elementary ages. So more time in math that increased all the things that you would like to increase in their kindergarten years went throughout their elementary years. Then another one in 2012, looked at 32 states plus the District of Columbia, looking to improve third grade reading. And they were trying to figure out what it is that we need to improve third grade reading. And they actually found out that the more time students spent in mathematics had found that it was not only the best predictor of how they did in math, but how they did in reading. And it also was even better achievement than their reading scores. So how they did in math was what correlated into how they did in reading and in mathematics. So math is really important. Excuse me. So we really want to make sure that we are trying to do as much math as we can in our after school time. So 21st century skills, they had asked CEOs and top executives in Fortune 500 companies, as well as other companies, about what are the skills that you're looking for your future employees. And all of them came up with these 4 skills: communication, collaboration, critical thinking, and then the last one is creativity, that they could think outside the box, basically. So these are skills that are really fine-tuned into mathematics if you take math out of being just a solitary individual activity and you make it more collaborative. And I really, really try to make math more collaborative with kids so that they're either playing a game together or solving a problem together, so that they get these great skills that they need for 21st century occupations. So out of school time, the more they found within 6th grade, if they've only spent about a minute or so out of school doing numbers or working with numbers, they found that they really just had a simple idea of numeracy. If they spent 5 minutes a day with mathematics, that they would have simple arithmetic activity, like they could do adding, subtracting, multiplying, and dividing. But it was if they did 20 minutes a day of math or math-like skills that they really became more mathematical thinkers. So some things that we can do in our after school time is to include games and activities and toys that help to bring about mathematical thinking. So I've included some here. This is definitely not all of them. But if kids have access to chess, Mancala, Blockus, Sudoku, Monopoly, play games like dots and boxes, which actually only needs a piece of paper, or the 24 game, which is a card game that can be purchased, but you could also just Google 24 game and you can have lots of examples of problems that kids can put numbers together to try to get the answer of 24. There's also having things that kids can play with, like pattern blocks, Legos, tanagrams, play money, dice, cards, and tiles is really important. A lot of kids do not have these type of products in their homes. These are luxury items that a lot of families can't afford or don't even think about to have, because not all kids come from a family where parents actually like mathematics. And so they're not getting enough exposure to really good math skills at home. So it's really important that our after school or our in school has a lot of things available for kids to manipulate and work on with regards to mathematics, so that they get their number sense and spatial reasoning and critical thinking skills going. So these are just some examples of that. Now, I think of math as being a superpower, because I've just said it really does increase other scores, but it also is the key indicator of how they do in the future, both academically and financially. So the more math students take, the better they become academically. And the more math they take, that because they're doing better academically, they tend to get better paying jobs out of school. They can get into colleges and then they can get better paying jobs. So mathematics is really a superpower to get kids, really advancing in their life. So problem-solving heroes, I often try to talk to kids about being a math champion and being a superhero and being really positive about mathematics. And I often tell them things like every student, one should have a journal, have a tool. To be a good math hero, you should have tools to help you become a math hero. And every student knows that superheroes need help, that asking for help is not a weakness, it's a strength. And so we need them to ask us questions when they come up. And knowing the answer right away doesn't make you a superhero. So we want to make sure that they know that the time that they spend thinking about things is important, and that their response afterwards, even if it takes them a while to come up with a response, is positive and should be rewarded, because knowing the answer right away means that you already had that knowledge. If you have to think about it a while and then you come up with the answer, means that you are actually really working your brain. So that's what we want our superheroes to do. And superheroes know that at first you don't succeed, you try again. So perseverance is one of those skills that's somewhat hard to teach, but through games and through activities, we really could get kids to try to start persevering, especially if they're working in groups. Kids are more apt to try harder if they're with others that are also trying with them. So that's why, team sports can be very positive for kids. So can team math activities. So research has shown that in third grade, students start to form their opinions about mathematics. What happens in third grade? What's the math skills that kids are learning in third grade? You can write that in the chat box, or you can unmute yourself if you would like. But what is going on in mathematics in third grade? Anybody want to respond? All right, well, in third grade, we start to have multiplication and division mastery. So if they are struggling with those masteries, they already start to feel like they're defeated in mathematics. So we want to make sure that they understand that mastery isn't the most important thing, but thinking about numbers is, and trying to get them to come up with solutions and strategies to get their math facts mastered. And I've done another class on this, and I have another video on this. So if you want more information about that, please let us know, and you can put that in the chat box as well. But getting them to master their math facts is what kind of gets kids to form their opinion as early as third grade. And then in fifth grade, they start to form what track they're going to take in mathematics. And what is the math skill that goes on in fifth grade? Any ideas or any suggestions on what skill fifth graders are working on that determines their kind of track in mathematics? Well, that would be fractions. So fractions is one of those things where students, they start to develop fractions as early as third grade and fourth grade, but fifth grade, they really start to have a mastery of multiplication and division of fractions, as well as addition and subtraction. That gets them to an understanding that they have to have the understanding of multiples and factors. So all of this is really important for kids to understand what this all means. And those kids that get that understanding could do better in algebra. So we really need to make sure that kids are very solid in those skills at fifth grade. And then in middle school, there's an interesting study in middle school that said, showed that test shows that there wasn't that much difference between minority students and the white students, except for the fact that on tests, the attempts were the difference. So minority students were much more willing to leave a question blank than to fill it in if they didn't know the answer. So we need to make sure that kids understand that even an attempt and a try is better than nothing. So we really need to make sure kids are attempting and trying mathematics. And that's why I'm a big advocate of kids working together on skills and learning to work as a group, because they're much more willing to try and take those necessary steps that we want them then to carry on into their test taking. So as I reported, again, math is a team sport. We really want them to try and learn and think together. And then that helps them do that independently after they've done it with each other as a team. Okay, so developing a classroom culture that supports problem solving. Teachers should talk. How much time should teachers talk? There's 30% or 70%. What do you think? It should be 30% or 70% of the time?
30.
It should be 30. Yes. Thank you, Carmela. Yeah, 30% of the time. So we really want kids to be talking the majority of the time, because that's how we're going to understand if they're understanding. So teachers can give directions, they can help clarify things, but for the most part, we really want the kids to do the majority of talking. And that's sometimes very difficult for teachers to allow kids to do that, because then volume comes up in the classroom, and so it's sometimes hard for teachers to allow that to happen. The next is what type of questions, open-ended or yes or no. So the answer on that one was we would really want to have open-ended questions. If we're just asking yes or no questions, we're really not getting any information from the child. And then how should teachers respond to answers? Should they say, oh, that's right or wrong, or say, can you expand and clarify?
Expand.
Yes, thank you. Expand and clarify. So who should you call on? The first person with their hand up, or wait and do a random selection? Anyone? Oh, go ahead.
Random selection.
Yes, so random selection. And the reason being is that the first child with their hand up, if you call on that child, then everybody else has stopped thinking. So as I did on this one, I didn't wait very long for a response. So everybody's just stopped thinking about it and they're like, okay, that's right. And so we really want time for people to sit down and think about a problem before you start calling on kids or calling for a response. And then this one, I kind of doubled up on the same one, is how do you respond to errors? Do you say that's wrong and next, or do you ask the child to explain their reasoning? And we kind of talked about this before. But we're really trying to get the child to expand their reasoning. Even if they've got something wrong, they're learning. So we want them to explain how they got that answer, if it's wrong, and where their thought process is, so that we can help guide them into realizing how it should have come out. So even though we all kind of solve problems in different formats, but have the child explain what format they're coming up with the reasoning. All right, so setting up groups for problem solving, as I've talked about, I really want kids to be in groups when they're doing their problem solving. And so setting up groups, I'm going to kind of go over different ways to think about it when you are doing it. As one is that you should have a group goal. So if you're going to give them a problem, the answer obviously is the goal to that group activity. But there could be more than that. It could be you want them to be able to express how they got their answer, or have different aspects to that problem discussed. And then keep the groups small, between 4 and 5 students is best. Even numbers are often better than odd numbers. And then it's establish flexible group norms, meaning that as things come up, we can adjust and adapt to them. Nothing ever set in stone. And then make sure you build trust and openness. Kids who feel like they're not going to be criticized or, told that they're wrong are much more willing to be open and explain what they're doing. And then create group roles. So in a group, you can say this person is going to be the administrator, and they're going to make sure everybody has a chance to talk. Somebody could be the recorder, somebody could be the timer. So you can give goals to each of the students in there. Or you could have one person has, a main role, and then you switch roles for each question that you're giving them if they're going to have more than one problem. So the roles should be changing so that each child has an opportunity to take on a lead role. And then grouping students, I'm just going to give you some background on grouping students so that you have an understanding of what happens, pros and cons, to different ways that you can group students. No way is the best way, but doing a random selection of different types of grouping gives you much more variety of learning styles and learning outcomes. So if you let students just choose their own groups, the pros to that is that you have a positive attitude, because mostly they're in with groups of kids that they want to be in with. But then you have, and your outcomes tend to be more positive, and it takes less planning. The cons is that it's less diverse, and some of the students are not selected, so they feel left out, and they can get off task from talking because they're very familiar with each other. Then you have the other one is a random grouping that you just pull sticks out of, with names on them out of a hat or whatever. Random grouping, the pros are, once again, it takes less planning. You're just having just a random drawing. Your groups tend to be more diverse, and it helps to build communication skills, because if they're in a more diverse group of kids, then they have to learn to communicate together more effectively. The cons are you can get negative attitudes because of what group has been selected, and that can cause lower group cohesion. So just knowing that with regards to random groups. And then the last one is educator selected based on academics. So the pros are they're organized based on their needs. And so it helps to develop learning. So you could do this a number of different ways. Like you could have a grouping of kids that are all at the same academic level, or you could have a group of kids that take on each level of understanding. So that takes more time. The cons are that it takes more time and that you could have achievement gaps within that. And you could have kids feeling like they're being labeled. So there are pros and cons to all of these, but when you're doing group selections, know that you should probably be doing a little bit of each one of these on a regular basis. Now, I talked about earlier about having tools, that math heroes have tools that help them along. And one of the tools, and I will have a PDF that you guys can have access to, that has this journal in it. And I love this little journal because it has little tabs in it that are easily accessible. Kids can write down the meaning of words on it, and they have this as a tool that they can pull up to use anytime that they're working on math problems, so that they have words that mean the vocabulary words that they have that mean certain things. So if they come across a problem solving story, they can determine what these words mean by using their little math journal. You can also, and I have a list of words here, so that there's addition words, subtraction words, multiplication words, and division words. And these are just some of them. There can also be a lot more. Having kids add them in as they come across them is important. So that's why this little journal works really nicely, is because they can keep adding on to it. Then there's also notes that they can take within journals that give them strategies, like you can give them multiplication strategies. In the journal, they can write down mnemonics that they can use, such as the dirty monkeys smell bad, really, which helps them with the division. And then there's tips on what to do with a problem solving story that you can circle, underline, box, evaluate, and solve. So there's different things that you can add to the journal that helps them out each time. And so as they get together in groups and stuff, they can bring their journal with them so that they can access this when they're trying to solve problems. So problem solving strategies that we're going to go over today are draw a picture, act it out, guess and check, look for patterns, work backwards, and make a list. So these are just some problem-solving strategies that kids can use. Some people are much more comfortable with certain problem-solving strategies. All of these apply to different problems, because some problems have to be worked backwards versus forwards and so forth. So because I can't picture things in my head, have to draw a picture almost all the time when I'm figuring out math problems. So that's my always go-to one, because I have to see it visually. I can't think of it mentally, because I can't picture numbers in my head. There's certain people who can't visualize things in their head, and I happen to be one of them. So I have to draw it out. So know that some kids can't visualize things. So when you're doing things like mental math, some people like me just can't do it because I can't picture the numbers in my head. So doing mental math is almost impossible for me. If you're asking me to add a bunch of numbers, subtract numbers, so forth, in my head, I can't do it. So just know that some of your students won't be able to do that, and just drawing a picture, writing it out is very important for them. So there's just certain ways that kids do learn. So these activities I'm going to show you are ones that you can use with your kids, and they're fun ones that you can bring up and have them work with in groups. So I'm going to start with our first one, and I'm hoping that you will unmute yourself and help answer these questions. All right. So the first one is draw a picture, and this is the problem that goes wrong with draw a picture. A group of students is standing in a circle. Every student faces someone across the circle. The student count off in order, starting with the number 1. Student 2 stands across from student 10. And then I'm trying to figure out how many students are in the circle. So this one actually could be acted out too. And you can use this with any number of students. You just don't want to start with 1, because that's obvious. So you would like to start with another student within the circle. So I'm going to give you a few minutes or a few seconds, I guess, to see if you can come up with the answer to this problem. And as you're thinking about that problem, I'm just going to bullet point each of the points of this problem, because when I'm working with kids, oftentimes it's hard for them to draw out the important information. So for me, I've always found that it's easy just to do little bullet points of the important information. So in this case, I know that there's two students standing across, or the second student is standing across from the 10th student. Numbers start at 1. Every student faces someone else, and then trying to figure out how many students are in the circle. So does anybody have an answer to this one? As yet, I can give another clue. So we know that 2 stands across from 10. So Nicole's guessed 18. Good. Anybody else have a guess? I'm going to give you another little clue here. So 1 would be across from what number? Yep, 1 would be across from 9. So if 1's across from 9, then
11, 4.
any guesses? Still have Nicole. Anybody else want to try? Are you guys drawing this out, I hope? So if 1's across from 9, we got 17. All right.
Yes, 17.
So Nicole's now on 17. So the answer to this one is actually 16, because of 9 being the 1 across from 1, that would make 8 the 1 across from the last number on there. So it's actually 16.
16. Mm-hmm.
And so you could have kids looking at this and saying, do you see any patterns within this? And you might notice that 1 across from 9. So 9 minus 1 is 8. 10 minus 2 is 8. 8 minus 16 is 8. So that all adds up to 8. So there should actually be 8 lines altogether going that form that little spiel or whatever, spiel, what's the word I'm thinking of? Spokes. That's the word I'm thinking of, spokes. So yeah, so that's the answer to that one. So it's a good one to do with kids. Like I said, they could draw it out. They could talk about it in their group together. They could also act it out. You could do this with any number of kids that you have. You could, let's say you have a group of 12 students, and you say, okay, you're going to form a circle in which everybody's across from each other. We're going to start with 3. What's the last number, students that you could have in the circle? So you could do this with kids as an act out activity as well. So the next one is act it out. So the one I do with act it out is going to be a visual spatial reasoning. So I have kids that have their blocks, and I show them an image of a set of blocks. I let them look at it for just a few seconds, and then I take those blocks away. And can you tell me how many blocks made up that image? Any guesses? You can say it out
19.
loud, or you can write it in chat. What was that?
19.
19. All right.
That wrong? No, that's wrong.
So when I
No,
work
it's
with
not
this,
19. No.
okay. But when I do this with kids, they can have their own blocks and they can try to recreate it as a group. They can talk about it and try to think about what is that they saw. What can they take from
28.
from the information they saw? So 28 is correct.
Yeah,
Yes.
28.
So this one I do with kids because I'm using a solid rectangular prism. In this case, I'm using a cube on this so that each side is equal. So I start really simple with things like cube. And I can do this with young kids. I can do it with kindergartners and first graders and so forth. And it's actually teaching them a really good, valuable fifth grade skill, which is volume. So although I'm not teaching them volume, they're starting to get the idea that when they're connecting their blocks and they're doing this visually and acting it out by making their block pattern, they're actually learning about volume. So it's a really good one to do with kids. And they're also learning about multiples of a number and so forth. So it teaches a lot of things that you don't actually have to teach. You're just trying to get them to recreate something and count up how many blocks it makes. And then you can get a little more fancy with it. And I'm going to show you this set of blocks. Give you a second to look at it. And then I'm going to take that away and then have you tell me, and if I had children, I'd have them recreate that figure and then tell me how many blocks were in that one. Anybody have any guesses on how many blocks were in this one, that last one? And Nicole guessed 30. And the answer is 30. So as that one got a little more complicated, because you have to realize that you're reducing a row on each side on the way up, it gets a little more complicated, but it gets those kids really thinking about good communications amongst themselves about just that very fact. Like, how many do you think was on the base? Each time there was 4 stories to it. How many blocks were taken out at each story of that building, the blocks? And you can have kids recreating that just with their own little building blocks. And you can get little connecting cubes for not a lot of money. They don't cost a lot. And even if you don't have the money for that, you can just get little, boxes that you can get materials out of. So you can do different things so that they can reconstruct that very thing and get a really good foundation of spatial reasoning and then some really good geometry understanding of, prisms and volume and so forth. So it's a really fun one to do with kids, and you can do it at a very young age with them. All right, the next one is another game called Guess and Check. And now this one you can do with kids. You just need to have 5 dice, and you're going to roll out the dice, but you're first going to tell them the name of the game. So the name of this game is called Petals Around a Rose, and the name is important. So there's 5 dice that I'll roll, and I will tell you how many petals appear. Your task is to figure out my rule for determining the number of petals. So this is a problem-solving one. They can get in groups once again and discuss what they think it is, and they can start guessing, and I can say yes or no to those. So here's the first roll of my dice. I've got a 1, 6, 3, 5, and 2. And the answer to that is 6. So if you have any guesses on how I got 6, you can keep them to yourself for right now, or you can write them out, or you can say them, but I'm not going to respond right or wrong at this point. I'm just giving you the first one. You'll have lots of opportunities to think about this one. So in this case, the answer is 6. I'm going to roll another time. And this roll gets me a 5, 2 5s, a 4, and 2 3s. And the answer to this one is 12. Sorry, my dogs just got in the room. Hang on a second. Sorry, my husband accidentally let my dogs in. you have 12 on this one. I'm going to give you another opportunity. And on this one, there's 8. So I have a 5, a 3, a 3, a 1, and a 2. Any guesses? On how I'm getting these numbers? You can ask me questions now that I've just given you a few examples. If you have any questions or have any ideas, you can unmute yourself.
For the first two, can you hear me?
Yes, I can.
Okay, for the first two, I thought it was the first, third, and fifth dice, but that doesn't work for the third one, so I'm not sure.
Okay, good guesses, good guesses. So I'm going to repeat this again. The name of the game is Petals Around the Rose. The name is important. Does that help anybody out? I'll give you another example. 66156. The name of the game is Petals Around the Rose. The name is important. And this one, sorry, is 4. Any guesses? All right, one last one. This one is 2. I can't see what it's behind my computer. 6, 3, 2, 2, and 4. And the answer on that one is 2. Just know when you're doing this with kids, kids are much more willing to give guesses. Adults aren't as willing to give guesses. So just know that kids will be much more engaged on just shouting out things. So any guesses?
Do the colors matter, or is that overthinking it?
That's overthinking, but
Okay.
I did use colors in there for a reason because it gives you another thing to think about. So yes, they're color coded for a reason, and that's to throw you off. That's a red herring. Any other guesses? Or anybody want any more tips? So think of petals. Think of a rose. Think of a center of a rose. Anybody? All right, I'm going to give you this one. So think of the center of a rose as the center dot. Are you guys getting this one now? So if you look at the first one, which numbers have center dots? The 1, the 3, and the 5. And the answer is 6. So anybody want to explain what I'm doing yet?
I'm clueless.
So what I'm doing is counting the dots outside the center. So if you look at the 1, 3, and 5, they each have a center dot. And
Okay,
the
now I see it.
outside dots are the petals.
Okay,
So
now I see it now.
yeah, so the only numbers that this ever have outside
Yes.
dots are the 3 and the
Yeah.
5.
Right.
So although this one isn't math where you think of math, it's not the adding and subtracting of numbers, which people automatically go to in mathematics. They think that they have to find, numbers that add up to something. And then the next is always to look at colors, because colors are your first draw in anything. When you look at things, color is almost always the first thing that you notice. So those two things are kind of red herrings, because what I'm trying to get you to look at something completely different, which is the patterning of things. So there's a reason I threw this one in here, is that it's a really good way to look at how patterns work and how to problem solve something that is completely kind of obscure of what they normally do. So, I kept on referring you to that title of the thing, which is important, but it's a really good one to do with kids because it gets them thinking about a lot of different things. And as they are processing, they're doing the same things that you were all doing, which was, did the colors matter? Did the numbers matter? I'm not seeing how the numbers relate to each other and so forth. So it's a really fun one to do with kids. And what I have them do is, instead of, if they think they have it, I'll have them whisper it in my ear. And if they have it, I'll tell them to be quiet. If they don't have it, and I then can use what they said to me to help the other kids try to come up with the answer. So they can come whisper in my ear what they think it is. If it's wrong, I would say to them, much like I did with you, the color doesn't matter, or the number doesn't matter. So I can give them clues to try to get them to an answer. But it's a good way to get all the kids thinking, and then the child that does have the answer correctly can keep quiet while the others still think. All right, so that's guess and check. And now this one is looking for patterns again, but with this one, I'm going to use poetry. So all those symbols that you see on the side, the 1 through 15, are ancient symbols that go back to 1000 AD Japan, in which they use symbols to represent stanzas in poetry. So this has some ancient history to it, which I think is kind of cool. But I'm going to use it with poetry that I just found, that is 4 lines long. So I'm going to read this poem to you, and I want you to listen to the rhythm of the poem. At night, I go on board and say, good night to all my friends on shore. I shut my eyes and sail away and see and hear no more. And that's from My Bed is a Boat by Lewis Robert Stevenson. And somebody did suggest I should have added a space between the poetry and the author, so as not to mess things up, which I agree with, and I didn't get done. So if you're looking at that poetry and you're looking over at these lines, I'm going to show you the first one. So the first one is represented by this 9, which means that the first line and the third line rhyme, and the second line and the fourth line rhyme. So it shows you how how poetry is very mathematical. It follows a pattern. So in this next one, who's with, I'm going to read it to you, and then I want you guys to think about which one of these symbols represents this part of a poem. Whose woods these are, I think I know. His house is in the village, though. He will not see me stop here to watch his woods fill up with snow. So which one do you think goes along with that one? And Stacy, I saw that you said, are you adding the dots around the middle dot? Yes, I'm adding up the dots around the middle on that previous one. So which one do you think that poem, which one of these lines do you think that poem represents? Any guesses?
It's 12.
You think it's 12?
12,
And
yeah.
Yep, 12 is right. Because you have the first, second, and fourth lines all rhyme, while the third line does not. Okay, my last one. Just I'm gonna have to move this box. Okay. Said the pelican to the elephant, I think we should marry, I do, because there's no name that rhymes with me, and no one else rhymes with you. That's from the poem, The Romance by Shel Silverstein. So which one goes along with that one, you think? Any guesses?
6.
6, yep. So 6 is the one that goes along with that. So you could have kids writing poetry that match one of these, or you can find poems that go along with these. I have in my handout, you'll have these symbols, and you'll have these selections of poems. So you can use that with your students, or you can find some others. You can have them then also figuring out what is represented by that question mark, and they'll have to go through all the different symbols that are there and try to figure out what's missing. And the one that's missing is that the first 2 lines don't rhyme, but the last 2 lines rhyme. So I like doing this with kids because it gets them to realize that math is everywhere. It's in poetry, it's in music. It's really is universal. So this is just a good example of that. All right, then this next one is working backwards. So when you work backwards, you really have to think about things differently. And not all kids have been trained on how to work a problem backwards. And it really requires some practice because they have to do the inverse operation. So in this case, I give them little puzzles like this to figure out on how to solve. So I put them in a group once again, give them this problem, just as general problem to give them with no support on how to get to the answer until they start asking for support. So I want them to think about what they're doing. So for example, I'm trying to figure out what the start number is. So I'm going to have to start at the end where I have an answer and work my way across. So in this case, I have 17, and then right before it, I have a +3. And this is where it gets tricky for kids, because to get the oval has to be added to the 3 to get 17. So in order to work backwards, you actually have to do the inverse operation, meaning I have to subtract the 3 to get that next number. So, oops, sorry, I'm going the wrong way here. So I've actually had to subtract. So it's 14 that fills in that space. So then I see the 14 and I see now -8. I realized that I had the answer 22 had to be -8 to get the 14. So now if you keep working across and you have kids use this type of puzzle, it gets them the real understanding of what it means to work a problem backwards, which is, like I said, something that they have to be trained in doing. It's really hard for kids to just understand this just on their own, that in order to work backwards, you have to do the inverse operation. So in this case, this next one, the answer for the rectangle would be, oops, I'm going the wrong way again. It'd be 31. And then 31, it would have to be -5 to get the 26. And then it would be the plus the 7, which would get you the 33 in the starting point. So working backwards is, there's a lot of problems that have kids having to work backwards, especially in standardized tests and such. So you really want to provide them opportunities where they're doing puzzles just like this and realizing how to work backwards. All right, so this, I'm going to go on to our last game, which will be one that we need to play together. And this game is one of my favorites, called Digit and Place, or Digit Place. And if you've ever played the game Mastermind, it is like the game Mastermind. And if you haven't played Mastermind, I'll explain how this is done. So numbers are made up of digits. So each one of these 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all digits that make up a number. So when we play this game, you're trying to come up with the number that I have written down, and I'll write down a number somewhere. And you are to figure out that number. And if I say that you have the right digit, it means somewhere in your number you have the right number, but it's not in the right place. If I say the word place, then it means you have the right number in the right place value. So I'm going to stop sharing this one, and we're going to do this as a group, and I'm going to do it on a whiteboard. So hang on a second. Let me get my whiteboard up. All right. I got to move people around here. Okay, so I need someone to unmute and give me, or write in chat, either way. and give me, although I can't access chat for some reason now, because I can only have the thing. So just unmute yourself because I can't see the chat at the moment. So somebody give me a 3-digit number, any number.
423.
Okay, 423. All right, now I'm going to tell you out of 423, you have one number in the right place, meaning one of these 3 numbers is the correct number in the correct place. So now you can guess another number. Any guesses?
406.
406. And this one, you have 0. Nothing is right.
128.
What was that again? I had 2 people talking at the same time.
128.
128. So in this one, you have one that's in the right place and one that's the right digit. So that means you have 2 numbers that are right, but only one is in the right place value. Sorry, my writing's kind of bad on this. Another guess?
$721.
721. So 721, you have one. I'm going to make my 7 a little better here. You have one digit, meaning only one number is right and it's not in the right place. So think about the numbers you've used. You've used a 4. Let's see, you've used 1, 2, 3, 4, 6, 8, and 0. And this one had 2 that were right. Anybody want to give another guess?
950.
950, 950.
Do 957. 957.
Okay, hang on a second. I'm just going to go
Sorry.
right over it. That's right. I'm just going to go right over it. Okay, 957. So over that one is 0 numbers. So right now we know 4, 0, 6, 9, 5, and 7 are not the numbers.
Right.
Okay, I'm gonna go with 213.
All right, this one has one in the right place and one that's the right digit. Another guess?
820. 827. I don't know.
827. I have one digit.
So 2.
Let's go with 823.
823.
Mm-hmm.
I have one digit, one place.
$283.
Yeah, that's what I was gonna say.
Sorry,
What is
280.
it? 283. 283. That's going to give you 2 in the right place.
Okay.
So one number is still wrong.
All right, 183.
Ding, 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 ding,
Yeah.
ding, ding. Yay. All right, nice job. So that is a great game to play with kids. It gets them to learn how to make lists, how to use logic and reasoning. You can also do this with colors. You can do 3 different colors in a cube that's 3 different, that's a 3 by 3, and do colors. And I can give examples of that one if you want later, but this is a really good one to get kids understanding place value, understanding how to read numbers and use logic and reasoning. And it's a fun one for them to do. And as they get better at this, you can add more numbers and go up into the thousands if you want to. So let me go back to my shared screen that I had. So that gets us to the end of this. So that's the whole presentation. Thank you for attending. I hope you got good information out of this. And the poll was up. I hope you had responded to that. We will be sending out, if you want a digital copy of the lessons that we did, I have that for you. You can contact me at the number or email provided. And I'm so glad that you attended, and I hope you got some good information from this. So thank you very
so
much. You're welcome.
Thank you. It was great.
So thank you. You may exit out if you want. You can ask me any questions at the end. I'll stay online for a little while if you want to ask any questions. And for Sarah, I'm going to do my little lights on thing. All right. Well, thank you all for attending. I really appreciate it. Have a good Thursday afternoon. Here's my